All right, welcome back. Today we're going to look at section 8.4a, dealing with rational expressions. Our learning targets today are to simplify rational expressions and to multiply and divide them. We're actually going to focus on the multiplying step today, and then tomorrow we'll look at the dividing. The first thing to notice is that when we have a rational expression, that means we have a ratio or a fraction. And so we have to look at restrictions. Those would be values that a variable cannot equal in a rational expression, because it would make the denominator of the expression 0. So we have two main strategies when simplifying rational expressions. The first one, when the denominator of a rational expression is just a monomial, where there's just one term, there's no plus and minuses between terms, then we can just use our rules of exponents to simplify. So the restrictions in this case would be simply what would make that variable equal to 0, which in this case would just be a 0. So looking at how we could simplify these, using those rules of exponents, our coefficients, those front numbers, let me redo my board quick. All right, let's try this again. Looking at our front numbers, those coefficients, we just reduce them like a normal fraction. 24 divided by -6 would give us -4. Okay, then looking at the variable parts, we look at where we have more of them. In this case, for our x's, we have more x's on the top. And if we just subtract our exponents, 3 minus 2, we'd have 1 extra on top. Looking at our y's, we have an extra 1 on the bottom in the denominator. So that would be our simplified expression. But notice that we have both an x and a y in the denominator. Those cannot equal 0. So we would have to list restrictions that x is not equal to 0 and y is not equal to 0. For the next one, we don't have a monomial on top. We can factor that. Looking for a GCF, we could pull out a 4x. What would be left on top would be a 2x squared minus a 3. And now when we look at what we can reduce out, there's a 4x both in the numerator and the denominator that we can divide out. So our simplified answer for this is just 2x squared minus 3. We do have to list the restriction, though, because looking at this, 4x cannot equal 0. Dividing out a 4, we'd have x cannot be 0. All right, but the bulk of our lesson will be the second strategy, where we really have a lot of factoring to do before we can do any kind of canceling. So, quick review of some different factoring patterns. For the numerator on this first one, there is a GCF of 2. We can factor a 2 out of everything. So if we do that, we end up with x plus 2 as the remaining factor. So 2 times x plus 2. For the denominator, we have a basic trinomial. So we're going to factor that into our 2 parentheses method. X squared, we'd split into x times x. The negative 18, we have several options to get a negative 18. We're looking for one that would get us a negative 7. And remember, we could have opposite signs. So we could also have positive 2 and a negative 9, which is going to get us our negative 7. So we need positive 2 and a negative 9. All right. Now, looking at restrictions, we want to list restrictions before we do any kind of canceling. So for this first one, we want x plus 2 not to be a 0, which means x cannot equal a negative 2. And for this one, x minus 9 cannot equal my 0. So x cannot equal a 9, because those would make the denominator 0, which is undefined. Once we have our restrictions listed, we can look for common factors that we can reduce out. And we have to take the whole factor. So notice that we have an x plus 2 factor, both in the numerator and the denominator. Because those match exactly, we can divide them out. And our simplified answer here would just be 2 divided by the x minus 9, with the restrictions that x cannot equal negative 2 or positive 9. All right, looking at our second one, we have a common GCF here on the numerator of an x, so if we factor that out, we have x plus 3 left. Looking at the denominator, we have a difference of squares pattern. X squared minus 9 would factor into x plus 3 and x minus 3. So again, before we do any kind of reducing, we want to look at restrictions. In this case, x cannot equal a negative 3 because it would make that factor equal to 0. And it can't equal a positive 3 because that would make that factor equal to 0. Now we look for common factors that we can reduce out. In this case, we have an x plus 3, both in the numerator and denominator. So final answer will just be an x for the numerator and an x minus 3 in the denominator. All right, our third example for simplifying. Once again, we have a GCF in the numerator. We can pull out a 3. If we do that, we'd have a 2x plus 1 left. Looking at the denominator, we have 4x squared plus 4x plus 1. Our a value isn't 1, so we do have to look at how we would split up that 4x squared. I do notice that a 4 here and a 1, those are both perfect squares, so let's see if we can split this 4x squared into 2x times 2x, and the 1 would be a 1 and a 1. Checking our insides and outsides, we get 2x for both of those, which would add up to our 4x in the middle. So we've correctly factored it. Now we're going to look at restrictions. Both factors in the denominator are 2x plus 1, so we only have to worry about figuring out this once. Subtracting our 1 over, we have 2x cannot equal negative 1. And then dividing out our 2, we would say x cannot equal negative 1/2. So we have our restriction listed. Now we can look for common factors. We do have a 2x plus 1 in the numerator that matches a 2x plus 1 in the denominator. We can take a 1 for 1, kind of reducing here. So even though there's 2 of them in the denominator, we really can only take out 1 of them. So final answer here would be 3 divided by 2x plus 1, with the restriction that x cannot be negative 1/2. All right, so that's simplifying, where we just have a single rational expression and we're trying to reduce it. Now we're going to shift to multiplying two rational expressions. The first step is to factor everything. We cannot do any kind of reducing until we have them in factored form. So we're going to factor everything. Then we're going to look at restrictions. Anything that would make any of the factors in the denominator 0 has to be restricted out. Then we're going to look for common factors that we can cancel. And as long as we're taking one from a numerator with one from a denominator, we can reduce those out. And then we'll combine what we have left into a single fraction. So looking at factoring, our first numerator here, we could take a 2 out. That leaves me a 3x minus 2. For the denominator, we just have an x minus 5. There's really nothing we can do to factor that. Looking at our second numerator, we have x squared minus 25. That's a difference of squares pattern. It factors into x plus 5 and x minus 5. And for the denominator, we have a 9x squared minus 12x plus 4. Again, we have perfect squares for our first and last terms. So I'm going to try that first, splitting the 9 into 3 and 3, and the 4 into 2 and 2. To get a positive 4, we either need 2 positives or 2 negatives. Since my middle number is negative, I'm going to try that. And checking, we've got negative 6 and another negative 6 to get my negative 12x. All right, so we've correctly factored everything. Now we look for restrictions. So for this one, we would say x cannot equal a 5, because if we put a 5 in there, the denominator becomes 0. These are both the same thing. 3x minus 2 cannot equal a 0. We'd add the 2 over and divide out our 3. So x can't be 2/3. All right, now that we've got our restrictions listed, we go ahead and look for things that we can reduce out. So I see an x minus 5 in the denominator here with 1 in the numerator there. You can take those out. I also have a 3x minus 2 that I can reduce 1 on top with 1 on the bottom. And what I have left, I have a 2 and I have an x plus 5 in the numerator. And in the denominator, the only piece I have left is a 3x minus 2. And we're going to let you leave the answer just like that. You do not have to multiply out that numerator. We want them in factored form. Okay, and then we just state with x not equaling a 5 or 2/3. Those are my restrictions. All right, for our second one here, again, trying to factor everything first. For my first numerator, I can take an x out. It leaves me an x plus 4. For the first denominator, x squared minus 16 is a difference of squares, x plus 4 and x minus 4. For the second fraction, I have trinomials, so we're going to go ahead and think of breaking those into our two parentheses. X squareds split into x and x. To get a negative 4, I can do negative 1 and 4, or the opposite combination, or negative 2 and 2. Since I'm trying to get a negative 3, I'm going to use this option, positive 1 with a negative 4. Looking at the denominator, again, it's a trinomial. X squared splits into x and x. We need two numbers that multiply to be 16 and add up to 8, so we can use 4s. All right, then looking for restrictions. Any denominators, any factors in the denominator can't be 0. So here we would say x cannot equal a negative 4. Here we'd say x cannot equal a positive 4. And then these two we've already listed here. X can't be a negative 4. All right, so our restrictions, final answer here, we're going to say x cannot equal a positive or a negative 4. Now looking for things that we can reduce out. We have an x plus 4 in the numerator and denominator. We have an x minus 4 in the numerator and denominator. And those are the only common things. So my final answer, I have an x and an x plus 1 as my numerator factors. And in the denominator, I have an x plus 4. I have two of them. So I can actually write that as x plus 4 squared to show that I have two of those. All right, so today your focus is on simplifying and then multiplying rational expressions. We want to make sure that you factor everything first, then list any restrictions before you cancel anything out, and then you can look for common factors in the numerator and denominator that can be canceled out. Let me know if you have any questions.